Good evening, everyone. This is the 11th live discussion session, problem solving session of week 11 for the course Soil Mechanics Geotechnical Engineering 1. The topic for today's discussion is Earth Pressure Theory, Part 2. The basic concept and some basic numericals of this chapter, of this unit, has been already covered in the previous class that was held on this Saturday, last Saturday, 5 to 7 p.m. In this class, a more detailed um, understanding of this chapter will be given based on numericals, mainly on the basis of numericals. So, this unit has a few MCQs and the others are purely numericals. Like the previous classes, in this class also, I'll be first of all dictating the questions. I'll be dictating all the questions at first, and then I'm going to give you some time, 15 or 20 minutes, to solve the questions, solve the numericals, and after that I will start discussing the solutions of the questions. So without further ado, I'll just go to the PPT right now. Yes. So those who will join, kindly start writing the questions. So again, this is the problem solving session for week 11 of Soil Mechanics Geotechnical Engineering 1. The topic is Earth Pressure Theory Part 2. Please write down the questions or take a screenshot, whoever will join the meeting. So I'll go to the first question. Yes, I hope the question is visible. In the case of passive state of plastic equilibrium, the major principal stress is the. In the case of passive state of plastic equilibrium, the major principal stress is the. Your options are vertical pressure, pore pressure, lateral pressure, or none of these. I'll repeat the question once. In the case of passive state of plastic equilibrium, the major principal stress is the. The options are vertical pressure, pore pressure, lateral pressure, or none of these. I hope it was clear. I'll go to the next question. Yes. The effect of cohesion in soil is to reduce the active pressure intensity everywhere by. Your options are 2C tan alpha, 2C cos alpha, 2C sin alpha, or 2C cot alpha, where C refers to the cohesion of the soil and alpha is the failure angle made by the failure plane with the plane of the major principal stress or the major principal plane, that is alpha. Generally we write it as 45 plus phi by 2. Phi is the angle of internal friction. So C is the cohesion, alpha is the failure angle. I'll repeat the question. The effect of cohesion in soil is to reduce the active pressure intensity everywhere by. The options are 2C tan alpha, 2C cos alpha, 2C sin alpha, or 2C cot alpha. I hope the question was clear. How does cohesion reduces the active pressure intensity in soil? By what amount? That has been asked. Okay. Okay. Next question. Yes. In the Bell's equation for active earth pressure on cohesive soils, the pressure intensity for Z equal to 0 is. I repeat, in the Bell's equation for active earth pressure on cohesive soils, the pressure intensity for Z equal to 0 is. Your options are minus 2C tan alpha, minus 2C cot alpha, 2C tan alpha, or 2C cot alpha. Again, in this question also, C refers to the cohesion of the soil and alpha is the failure angle or the angle made by the failure plane with the plane of the major principal stress. I'll repeat the question. In the Bell's equation for active earth pressure on cohesive soils, the pressure intensity for Z equal to 0 is option 1 minus 2C tan alpha, option 2 minus 2C cot alpha, option 3 2C tan alpha, option 4 2C cot alpha. Next question. Yes. For smooth walls, the value of wall friction is taken as. For smooth walls, the value of wall friction is taken as. Wall means the wall means retaining wall, the one that contains the backfill. For smooth walls, the value of wall friction is taken as. The options are 1 by 3 phi, option 2 2 by 3 phi, option 3 3 by 4 phi, option 4 0. Phi is the angle of internal friction of the soil. I'll repeat the question. For smooth walls, the value of wall friction is taken as. The options are 1 by 3 phi, 2 by 3 phi, 3 by 4 phi, or 0. Okay. Now, these are the only MCQs. We'll come now straight to the numericals part. Yes. The first numerical. A 6-meter high vertical wall supports a saturated cohesive backfill with a horizontal surface. The top 3 meter of the backfill weighs 18 kilonewton per meter cube and has an apparent cohesion of 18 kilonewton per meter square. The bulk unit weight and apparent cohesion of the bottom 3 meter of the backfill are 20 kilonewton per meter cube and 24 kilonewton per meter square, respectively. What is the likely depth of tension cracks behind the wall? If tension cracks develop, what will be the total active pressure? Draw the pressure distribution diagram and determine the point of application of the resultant pressure. Here resultant pressure means the total active pressure. You have to only find out the total active pressure, and that pressure, the magnitude you have to find out, and the point of application of the pressure in the pressure distribution diagram that you draw. Okay. I'll repeat the question. A 6-meter high vertical wall supports a saturated cohesive backfill with a horizontal surface. The top 3 meter of the backfill weighs 18 kilonewton per meter cube and has an apparent cohesion of 18 kilonewton per meter square. The bulk unit weight and apparent cohesion of the bottom 3 meter of the backfill are 20 kilonewton per meter cube and 24 kilonewton per meter square respectively. What is the likely depth of tension cracks behind the wall? If tension cracks develop, what will be the total active pressure? Draw the pressure distribution diagram and determine the point of application of the resultant pressure. I hope the question was clear. I'll go to the next question. Yes. A retaining wall 4-meter high supports a backfill for which the cohesion is 20 kilonewton per meter square, angle of internal friction phi equals to 30 degree, and unit weight, this gamma, equals to 20 kilonewton per meter cube, with the horizontal top flush with the top of the wall. It means it is level with the top of the wall. There is no inclination of the top of the backfill surface. The backfill carries a surcharge of 20 kilonewton per meter square. If the wall is pushed towards the backfill, if the wall is pushed towards the backfill, compute the total passive pressure on the wall and its point of application. So depending upon the movement of the backfill, you have to find out the type of pressure. Those who have joined, please write down the question from the current one. I'll repeat the question once. A retaining wall 4-meter high supports a backfill. Cohesion of the backfill is 20 kilonewton per meter square. Angle of internal friction is 30 degree. Unit weight gamma is 20 kilonewton per meter cube with horizontal top flush with the top of the wall. The backfill carries a surcharge of 20 kilonewton per meter square. If the wall is pushed towards the backfill, compute the total passive pressure on the wall and its point of application. Clear? I'll go to the next question now. A wall of 6-meter height, just a moment. Yes, a wall of 6-meter height retains sand having a unit weight of 20 kilonewton per meter cube and friction angle of 30 degree. If the surface of the backfill slope upwards at 15 degree to the horizontal, find the active thrust per unit length of the wall. There is a force per unit length of the wall. I'll repeat the question. A wall of 6-meter height retains sand having a unit weight of 20 kilonewton per meter cube and friction angle of 30 degree. If the surface of the backfill slope upwards at 15 degree to the horizontal, obviously sloping upwards away from the retaining wall. If the surface of the backfill slope upwards at 15 degree to the horizontal, find the active thrust per unit length of the wall. Find the active thrust per unit length of the wall. Okay. I hope the question was clear. I'll go to the next question. Yes. A retaining wall 4 meter high has a smooth vertical back. The backfill has a horizontal surface in level with the top of the wall. There is a uniformly distributed surcharge load of 36 kN per meter square intensity over the backfill. The unit weight of the backfill is 18 kN per meter cube. Its friction angle and cohesion are 30° and 0 respectively. Determine the magnitude and point of application of active pressure per meter length of the wall. I'll repeat the question. A retaining wall 4 meter high has a smooth vertical back. The backfill has a horizontal surface in level with the top of the wall. There is a uniformly distributed surcharge load of 36 kN per meter square intensity over the backfill. The unit weight of the backfill is 18 kN per meter cube. Its friction angle and cohesion are 30° and 0 respectively. Determine the magnitude and point of application of active pressure per meter length of the wall. I believe the question was clear. I'll go to the next question. Yes. Vertical excavation. Yes, this is the next question. A vertical excavation was made in a clay deposit having weight of 20 kilonewton per meter cube. It caved in after the depth of digging reached 4 meters. Taking the friction angle to be 0, calculate the value of cohesion. If the same clay is used as a backfill against a retaining wall up to a height of 8 meters, calculate number 1 total active earth pressure and number 2 total passive earth pressure. I'll repeat the question. A vertical excavation was made in a clay deposit having weight of 20 kilonewton per meter cube. That is the unit weight. It caved in after the depth of digging reached 4 meter. Taking the friction angle to be 0, calculate the value of cohesion. If the same clay is used as a backfill against a retaining wall up to a height of 8 meter, calculate number 1 the total active earth pressure and number 2 total passive earth pressure. Okay. Next question, the last question. Yes. A soil mass is retained by a smooth backed vertical wall of 6 meter height. The soil has a bulk unit weight of 20 kilonewton per meter cube and friction angle of 16 degree. The top of the soil is level with the top of the wall and is horizontal. If the soil surface carries a uniformly distributed load 4.5 kilonewton per meter square, determine the active thrust on the wall per meter and its point of application. This is basically a similar question like the last one, just for practice sake. I'll repeat the question once. A soil mass is retained by a smooth backed vertical wall of 6 meter height. The soil has a bulk unit weight of 20 kilonewton per meter cube and friction angle of 16 degree. The top of the soil is level with the top of the wall and is horizontal. If the soil surface carries a uniformly distributed load of 4.5 kilonewton per meter square, determine the active thrust on the wall per meter and its point of application. Sorry. So these are the questions. I'll give some time, around 20 minutes. I'll start discussing the solutions around around 7 o'clock. Okay. After 20 minutes approximately. Please solve these questions. You can either solve the MCQ or solve the numericals first, but go for the numericals first because they might be a bit time taking. All these numericals might be a bit time taking because in most of the cases you might have to draw the pressure distribution diagram. Okay. So draw them very carefully. Anyway, I'll be giving the solutions. Okay, so I will start with the solutions part. The first question, yes, the first question was, just a moment. Yes, okay. In the case of passive state of plastic equilibrium, the major principal stress is the answer is lateral pressure. Why? Because for passive state, if this is the backfill and there is a retaining wall, the wall moves towards the backfill. So the major principal stress is lateral. In the case of active state, if the wall moves away from the backfill for active pressure, the wall moves towards the backfill for the passive pressure. So in the case of passive pressure, it exerts a lateral pressure, which is the major principal stress. And in the case of active pressure, it moves away. The vertical stress is the major principal stress. So here the question was for the passive state of plastic equilibrium. Here the major principal stress is the lateral pressure. The major principal stress is the lateral pressure. Okay. Next question. The effect of cohesion in soil is to reduce the active pressure intensity everywhere by, the answer is option 4, 2C cot alpha. 2C cot alpha. Because as per the Bell's equation, which have been discussed in the next question also, I'll just write it over here. The Bell's equation, active pressure in a cohesive soil, gamma Z cot square alpha minus 2C cot alpha. Okay. So this is the pressure, and this pressure gets reduced by an amount of 2C cot alpha because of the cohesion. So cohesion, it reduces the active pressure intensity everywhere by an amount of 2C cot alpha. Similar question have been mentioned in the next one. In the Bell's equation for active earth pressure on cohesive soil, the pressure intensity for Z equal to 0 is the pressure intensity. The same equation, this is the Bell's equation, PA equals to gamma Z cot square alpha minus 2C cot alpha. You can see over here this 2C cot alpha is the constant value not varying with the depth, whereas this is something varying with the depth. Okay. So when Z equal to 0, this whole thing becomes equal to 0. The pressure that remains is equal to minus 2C cot alpha. Minus 2C cot alpha at for PA at Z equal to 0. At Z equal to 0. Okay. I hope it was clear. Next question. For smooth walls, the value of wall friction is taken as. Now in this case, I will just discuss something. The value of wall friction for smooth walls is taken as del equals to 1 by 3 phi. This is for smooth walls. 2/3 phi is taken for ordinary retaining walls. Ordinary retaining walls. 3/4 phi is for rough walls. And 0 is for vibrations. Walls subjected to vibrations from the backfill. Okay. For the active earth pressure, the equation for the coefficient of active earth pressure in terms of the value of wall friction can be given as sec theta into cos phi minus theta divided by root over of cos theta plus del plus again root over of in denominator cos beta minus theta and in numerator it is sin phi plus del into sin phi minus beta. Okay, so since I have told over here the value of wall friction is in terms of phi, it generally does not exceed more than 15 degree. And the last class I have told that the wall friction, what does it do? It reduces the value of active pressure, increases the value of passive pressure. So if this is Ka, coefficient of active earth pressure, we can see from here the value of theta being the angle made by the back of the retaining wall with the vertical. Is theta, and this beta is the backfill angle made by the soil. Okay, this is beta. Phi is the angle of internal friction. Now value of theta is very less and value of del is also very less. So this part generally is less than 45 degree, for which the value of cos is high. However, the value of phi is more than the value of theta, and phi plus del, this part is generally more than 45 degree, for which the value of sine is more. So in this equation, for the coefficient of active earth pressure, the denominator increases because of the addition of del. The denominator actually increases, so the overall value of Ka, coefficient of active earth pressure, it reduces. And we know Ka is equals to 1 by Kp, Kp equals to 1 by Ka. So in this case, we can say that the value of coefficient of active earth pressure reduces because of the wall friction. Hence, wall friction tends to reduce the magnitude of active earth pressure, and vice versa, it increases the value of passive earth pressure. This was one of the theory I have explained in the last class. The numerical validation for that I am giving now. Okay. So next question. The numerical will start now. I'll just Control C B. I'll do the numerical here, so I need some space. Yes. So in this sum, we are told to find out total active pressure and the depth of tension crack and the pressure distribution diagram. So first of all, we'll write the equation, that is PA equals to gamma sat Z minus 2C. Okay, for saturated clay, here saturated clay is given, we'll assume phi equal to 0. Okay, tan square alpha equals to 45 plus phi by 2, phi equal to 0, tan 45 equals to 1. Okay, now For the topsoil, when Z equals to 0, PA for Z equal to 0 will be equal to how much? Minus 2C. And at Z equal to 0, cohesion is how much? Cohesion is 18. So it is minus 36. It is minus 36. 36 kilonewton per meter square at Z equals to 0. Okay. Now, assuming that the tension crack is in the top layer only, top 3 meter layer only. So, the tension crack depth is Z0 equal to 2C by gamma. Saturated unit weight we'll be writing over here as 18. So 2 into 18 by 18, that is 2 meter. That is 2 meter. So the depth of the tension crack over here is 2 meter. This is the answer of the first question. Likely depth, assuming that the tension crack is in the first layer only. Tension crack is in the first layer only. Okay. Now, at a depth of 3 meter for the upper soil, PA for Z equals to 3. It will be how much? Gamma sat Z, that is 18 into 3, minus 2C, minus 2 into 18. It will be equals to 18 only for the upper soil. 18 kilonewton per meter square for the upper soil. Now, for the lower soil, we have to see that at any depth Z more than 3, the equation becomes what? PA equals to 18 into 3 plus 20 into Z minus 3. Why 20 to Z minus 3? After the depth of 3 meter, below that, the unit weight, saturated unit weight is 20. This 20 minus twice of cohesion. What is the cohesion below 3 meter? It is 24. So 2 into 24. This equation now becomes PA for Z more than 3. It becomes, it is 6. Yes, 6 plus 20 into Z minus 3. 6 plus 20 into Z minus 3. We can also, modify this equation like this. It is 20Z, 20 to 360 minus 54. So we'll just solve it. So for Z equals to 3 for the bottom soil, Z equals to 3 for the bottom soil, PA becomes equals to 20 to 360 minus 54, it is equals to 6 kilonewton per meter square. And for Z equal to 6 meter, that is below, PA becomes how much? PA becomes 120 minus 54, 66 kilonewton per meter square. Now it was a pressure distribution diagram. Okay. This is negative pressure. At topsoil, the value is 36. This is 0, that is 2 meter depth of tension crack. This is again 1 meter, and this is 3 meter. Here the value of the pressure is 18 for the topsoil. For the bottom soil it is 6, and for this is 66. Okay. Now we are told to find out total active pressure. For this, we will be neglecting the tension crack because this is the overall positive pressure acting to the soil. So neglecting the tension crack, we have two diagrams, one triangle and one trapezium. So if the triangle is P1, the value of the total force is the area of triangle, that is half into base into height, half into 1 into 80. So this becomes 9. This is P1, 9 kilonewton per meter. This is P2, half into sum of the parallel sides into height for trapezium, that is half into 66 plus 6 into 3, gives the value of the area of trapezium or the thrust per unit. Okay, just a moment. Yes, it is per meter. Okay, or the thrust per unit meter for the second one is 108 kilonewton per meter. Okay. Now the first one is acting at a depth of how much from the base? This is 3 and this is 1 by 3. So 3 plus 1 by 3 is 4 by 3, that is, no sorry, it is 10 by 3, that is 3.33. 3.33 meter from base. And this is acting at what distance? For this, the formula for the trapezium is h by 3 into b plus 2a, that is longer by shorter, b and a, divided by a plus b. Okay, so if you solve this, b plus 2a, 66 and 6, 66 plus 12 divided by 72 into the height is 3. Yes, 1, that is 1.083 at the rate 1.083 meter from base. Now we have got the two values of force per unit area and their respective point of application. So total pressure P will be equals to P1 plus P2. That will be equal to how much? 117. And how to find, not meter square, meter. And how to find out the location? Z bar, location of this P equals to, if this is Z1, this is Z2, it will be P1 Z1 plus P2 Z2 divided by P, P1 plus P2. And this ZP will have a value of approximately 1.26 meter from the base. Okay. So first of all, we divide the pressures in the form of top soil, bottom soil, and then we find out the individual pressure intensity, draw the pressure distribution diagram from which the active pressure is the depth below the tension crack. We find out the individual pressures of the area and then we find out the total pressure and the point of application. Okay. Next question. Yes, I'll again retaining wall top of this. Okay. So here we have been told the value of cohesion is 2. Not cohesion is not 2, cohesion is 20. Okay. Position is 20, phi is 30, and gamma is 20. So here wall is pushed towards the backfill. For passive pressure, the value of Kp, coefficient of passive earth pressure, is equals to tan square 45 plus phi by 2. Phi equal to 30 degree, 30 by 2 15 degree, tan 60 root 3, then this becomes equals to 3. Kp is equals to 3. Okay. Now for the surcharge, if it is P1, then it will be equals to Kp into Q, that is 3 into 20 is the surcharge, I believe. Yes, surcharge into 20, that is 60 kilonewton per meter square pressure intensity. Next, for the backfill, if it is P, I can write like this: gamma H Kp plus 2C root over of Kp. Now we know this is a constant. This will not vary as per the depth. So we'll write this as P3 or as P2 and this as P3. The value of P2, 2C root over of Kp, this is 2 into 20 into root 3, we obtain as 69.28 kilonewton per meter cube, per meter square. Okay, and the value of P3, that is gamma H, gamma into is 20, H is 4 and Kp is 3. 20 into 4 into 3, it gives us 240 kilonewton per meter square. Okay, now we draw the pressure distribution diagram. We draw it now. So first of all, there was a surcharge. There was a surcharge, then there was a constant, weight due to the increment due to the cohesion, and then there was the pressure of the backfill. So surcharge pressure, this is P1, due to cohesion increment this is P2, due to backfill itself this is P3. Okay, this is P1, P2 and P3. Now the total force P1, then this is P2, then this is P3, a bit below because it is a triangle. This is P2, sorry. Yes. P1 will be how much? Base length into breadth for the rectangle. So it is 4 into P1. What is the value of P1? P1 is 60. 4 into 60. 4 into P1, that is equals to 240 kN per meter, acting at, from the base it is 2 meter, that is Z1. Okay, Z1 is 2 meter. What is P2? Again 4 into P2. What is P2? 69.28, approximately 277.1 kilonewton per meter, acting at the rate, again 2 meter from the base, Z2 suppose. What is P3? Area of the triangle, half into 4 into P3, half into 4 into P3. What is P3 is 240, so it is 480, 480 kilonewton per meter at the rate acting at 4 by 3, 4 by 3 meter from the base Z3. Okay. So total pressure, that is P, will be equals to P1 plus P2 plus P3. Approximately 997.1 kilonewton per meter acting at Z bar P. That will be equal to how much? Total pressure P1 Z1 plus P2 Z2 plus P3 Z3. That gives us a value of approximately 1.68 meter from base. 1.68 meter from base. That means if this is 2, this is 1.33, it is approximately 1.68 here. P is acting. Okay. I hope the solution was clear. Next question. Yes, a wall of 6 meter height retains a unit 20 and friction angle of 30. Surface upward 15 degree. Okay, so the slope, the backfill has a sloping surface. For that, we have for active pressure, the coefficient of active pressure for a sloping surface is given as Ka equal to cos beta into cos beta minus root over of cos square beta minus cos square phi divided by cos beta plus root over of cos square beta minus cos square phi. Okay. Here beta equals to 15 degree. 15 degree. Okay. Phi equal to 30 degree. Put in the value, we get the value of Ka to be equals to approximately 0.3729. 0.3729. Now we are asked to find out active thrust per unit length of the wall. For that, the active thrust per unit length of the wall, sand, so no cohesion. So the formula is half into Ka into gamma h square. What is the value of gamma? Gamma is 20, h is 6, and just solve it. 0.3729 into 20 into 36. 134.24. 134.24 kilonewton per meter. Okay, so this is the main part, finding out the coefficient of active earth pressure for a backfill with a slope. For a backfill with a slope. Okay. The next question was Yes, retaining wall of 4 meter high, smooth vertical backfill has a horizontal surface. Backfill has a horizontal surface. So, just a moment, I think there was a network issue and the meeting got, yes. Let's rejoin the meeting now. Okay. So the backfill is horizontal. There is a UDL, uniform distributed load, surcharge of 36, intensity over the backfill, unit weight is 18, friction angle and cohesion 30 and 0. Magnitude and point of application. This is a similar question. I'll just show you the solution. Yes, this is the solution. So here we are asked to find out the active pressure. Then find out the value of Ka, coefficient of active earth pressure, 1 minus sin pi by 1 plus sin pi, 1 by 3. For surcharge, the intensity of pressure is the coefficient into surcharge intensity, 1 by 3 to 36, it is 12. It is constant, so it is 12, a rectangle of height 4 meter and width 12 kilonewton per meter square. Okay. Now for the backfill, since there is no mention about the cohesion over here, cohesion is 0, so it will be Ka gamma h, the intensity of the pressure due to backfill. That is equal to 24. So now the total pressure intensity at the base of the wall, P1 plus P2, that is 36 kilonewton per meter square at the base of the wall. It is the pressure intensity. Now finding out the total thrust per unit length of the wall. So P1, capital P1 equals to small p1, the intensity into the height. Intensity into the height, that is 48. Acting at 4 by 2, 2 meters from the base. Now the resultant pressure will be P1 plus P2, for which P2 equals to how much? It is the area of the triangle, half into P2 into h, it's 48, acting at 4 by 3, that is 1.33 from the base. Now adding these two, P1 plus P2, we get the value of P. Total thrust per meter length of the wall is 96 kilonewton, this one. And then the point of application is Z bar equals to P1 Z1 plus P2 Z2 divided by P1 plus P2. P1 is 48, Z1 is 2 meter, P2 is 96, P2 is also I think 48, yes, P2 is also 48 and Z2 is 4 by 3. So this gives us a value of 1.67, the value of Z bar, the point at which, the point from the base, above the base, at which the total thrust per meter length of the wall is acting. Okay. I hope the solution was clear. Next question. Vertical excavation made in a clay deposit having weight of 20. It caved in after depth of digging 4 meter. Taking the friction angle to be 0, calculate the value of cohesion. So here friction is 0. To find out the cohesion. So this is finding out earth pressure in a cohesive soil. For active pressure, we'll be using the Bell's equation again. So just see the solution. So for the value of cohesion, to keep in mind the height up till which it can support itself, unsupported vertical depth, unsupported vertical cut, hc equals to 4c by gamma into tan alpha. Now tan alpha for phi equal to 0 is equals to 1. So hc equals to 4c by gamma, from which we can find out the value of cohesion, hc into gamma by 4. Now height is how much? Height is 4, as it has been mentioned over here. It caved in after the depth of digging reached 4 meters. So it can support itself up till 4 meters. So 4 meter is the unsupported vertical cut. Okay. So now HC is 4 meter, gamma is 20. The value of cohesion is 20 kilonewton per meter square, as has been asked in the question. Find the value of the cohesion. Is 20. Now total earth pressure, active earth pressure given by here. This is the Bell's equation actually taken from the book. So in this case, here there is a mistake. That is, when you are considering the total active earth pressure, that is the thrust per meter length of the wall, the value of H will be in terms of square, H square over here. Okay, please correct this. It will be H square, because the intensity of pressure, because the intensity of pressure small pa is equals to half gamma H, what's not the half, it is gamma H cot square alpha minus 2c cot alpha. So in this case, this equation upon integration, it will be H square by 2, and this will have a value of H, which is fact over here, but they forgotten to write H square over here. Anyway, just correct this equation. Half gamma H square cot square alpha minus 2ch cot alpha is the value of the total active earth pressure. Okay. Now gamma is 20. The new height, that is the same clay used as a backfill against the retaining wall up to a height of 8 meters. So the new H is 8 meter. The previously HC was the critical height. Now H is 8 meter. So 8 square into 1. Why 1? Because tan alpha equals to 1. So cot alpha will be obviously equals to 1. Minus 2 into C, 2 into 20 is the value of cohesion into H cot alpha. The value of the total active earth pressure is 320 kilonewton per meter. Now for the total passive earth pressure also, here the value of cohesion, it increases the magnitude of the passive earth pressure. The value of cohesion, it increases the magnitude of the passive earth pressure. So for this, the passive earth pressure, the intensity, not the thrust, the intensity of the passive earth pressure given by the equation gamma H tan square alpha plus 2c tan alpha, which upon integration gives us H square by 2, and here we have an additional H. This gives us the equation PP, that is the passive earth pressure, total passive earth pressure is equals to half gamma H square tan square alpha plus 2ch tan alpha. Okay, again over here H is equals to 8, gamma equals to 20, cohesion equals to 20, tan alpha equals to 1, tan square alpha equals to 1. We get a value of approximately, no, the value is 640 plus 320, it is 960. 960 kilonewton per meter is the total passive earth pressure per meter length of the wall, and 320 kilonewton per meter is the total active earth pressure per meter length of the wall. I think that has been asked in the question only. Yes, total active earth pressure, total passive earth pressure. Okay. I hope it was clear. Okay. Next question, the last question. A soil mass is retained by a smooth backed vertical wall of 6 meter height. Okay. The soil has a bulk unit weight 20, friction angle 16, topsoil is level, top of the wall is horizontal, soil surface has a UDL uniform distributed load of UDL of 4.5 kilonewton per meter square. The active thrust on the wall per meter and this point of application. Okay, very simple question. Same question actually. So there is a surcharge for which there will be an additional pressure, that is intensity of P1, which has the formula P1 equals to active earth pressure. So Ka into Q, Q is the surcharge intensity and Ka is the coefficient of active earth pressure, which is equals to 1 minus sin phi by 1 plus sin phi. Here is the value of phi, that is the value of friction is 16 degree. So the value of Ka, coefficient of active earth pressure, is equals to 0.568. 0.568. So P1 is Ka into Q, that is the value of 2.55. Now the total pressure is P1 equals to height into P1, this is the width. So 6 into 2.55 gives us 15.332. This is the value of P1 acting at half of the height of the rectangle, that is 3. This is Z1. Again P2, that is the base of the triangle P2, it is Ka into gamma h, coefficient of active earth pressure, multiplied by the unit weight multiplied by the height of the backfill. So this is the value of 68.16, and then finding out the area of triangle, that is half into base into height, half into P2 into height 6, we get P2 total thrust as 204.48, acting at 1/3 from the base, that is 6 by 3 into 2 meter from the base, Z2. So again total pressure is P1 plus P2, 219.812 kilonewton per meter length of the wall, and then Z, the point of application of this total pressure, equals to P1 Z1 plus P2 Z2 divided by P1 plus P2, approximately 2.07 meter above the base. Okay, so I hope the numericals gave a more detailed idea on how to solve the problems, how to deal with the problems of earth pressure in both cohesionless and cohesive soils, with or without surcharge, So I believe the earth pressure theory is almost over right now. So this unit is completed. Those who have joined, thank you for joining the class. This brings us to the end of our discussion. Next class will be on the next Monday, coming Monday. The topic will be, I think, a basic introduction on the stability of slopes, which will be followed by summary session on the very next day. Okay, so thank you.